Today, in this video lecture, we will see concept shear stress. When two or more parts are required to be connected by means of bolts, screws, or nails to prevent relative motion between them, the connectors are called as shear connector. This figure is plane with connector. This portion is connector. Consider this part, bottom part is 1 and top part is 2. This part 1 and 2. When two or more parts, these two parts are connected by means of bolts, this is bolt, screws or nails to prevent relative motion between them. This relative motion. The longitudinal shear along the shearing surface are resisted by shear connector. This longitudinal shear are resisted by this shear connector. The typical types of shear connectors are angle shear connector, channel shear connector, stud shear connector, or steel bar shear connector. Consider two wooden planks placed one above another. Consider this one as wooden plank and this is second wooden plank, and these both wooden planks are one above another. When these planks are used as a beam without any connection, see here, not any connection seen between both of these planks, they will slide over each other. See, if force acts along this direction, they will slide above each other along their contact surface. So to avoid the sliding of these planks, they act as a single unit. It is necessary to interconnect these planks by proper shear connector, by this shear connector. So we will see design steps for shear connector. First, the definition of shear flow. Shear flow is the longitudinal shear per unit length transmitted across the section. Shear flow is the longitudinal force per unit length transmitted across the section, and this shear flow is denoted by Q. And horizontal shear per unit length is shear stress tau multiplied by B, and this tau formula is SAY upon BI, and this B as it is, this B get cancelled, so shear force per unit length is SAY upon B. This is first design step. Second step is shear force at each connector. So formula for shear force at each connector is equal to horizontal force multiplied by spacing or pitch. This shear force at each connector is capital F is equal to horizontal shear is this Q multiplied by spacing is denoted as P. Next step is to calculate shear strength of connector. Shear strength of connector is equal to shear force at each connector. Shear strength of connector denoted as capital F is equal to shear stress multiplied by area of connector. Area of connector or area of bolt. Shear stress is SAY upon BI and area of connector. So these are design steps for shear connector. Design steps are shear flow. Shear flow is the longitudinal force per unit length transmitted across the section. Horizontal shear force per unit length is small q is equal to tau into B, and this horizontal shear per unit length is SAY upon B, and shear force at each connector is equal to horizontal shear multiplied by spacing or pitch. F is equal to Q into P. This is shear force at each connector, for each connector shear force, and this is horizontal shear force per unit length. See difference between both of these. Horizontal shear force per unit length is small q is equal to SAY upon B, and shear force at each connector is F is equal to Q into P. And shear strength of connector is F is equal to SAY upon BI into area of connector. Thank you very much.